how do you order these? Well, better orbital overlap lowers the energy. So for almost all atoms, you'll get this energy diagram that looks like this. So you've got the sigma S, the sigma anti-bonding, you've got the sigma P, you've got the two pi or side-on bonding, then you've got the two anti-bonding, and the sigma star, okay? So almost all the atoms, when you combine, you'll get this more conventional ordering. However, if you have a Z, and remember the Z is the number of protons, that are less than or equal to 7, then you get this kind of different ordering. And so that's why we did carbon. So boron, carbon, and nitrogen, if you have one of those atoms that have p orbitals, you'll get this ordering, okay? And this is just based on how those orbitals overlap, right, when you stick them together. And so the better overlap lowers the energy. And so that's why when we drew carbon, we drew the pi bonds lower than the sigma bond. Okay, so I just wanted to show you like 2 more examples. So here we have the molecular orbital diagram for oxygen, right? And oxygen has 1, 2, 3, 4, 5, 6 valence electrons, right? We've got 2 in the 2s orbital that looks like this, and 2 in the 2p. So we've got the p, that's the px, the py, which is coming in and out of the board, and the pz, which is up and down. Okay, and we're going to combine that with the other oxygen atomic orbital, right? So that we can form our molecule, which is O2. So same pattern, right? We take and put these 2 together. When we put them together, we get this sigma bond that looks like this, okay? The sigma anti-bonding, when we put it together, we've taken and subtracted them, so it looks like this. Okay, the px orbitals, well, those are these 2 that come end-on with each other, right? The noses come together like they're punching. And so when we draw that one, we draw a little side, a big in the middle, and a little on the outside. And one of these gets filled in, whether I fill in the outer 2 or the inner one, right? So there's my sigma bonding orbital for the px. The py and the pz, remember they're parallel to each other. So the pz is up and down, the py is in and out of the board. Conventionally, you can order the axes however you want. And when I draw these, I draw my nucleus, and then I have a big cloud on the top and a big cloud on the bottom, and one of those fill in. Okay, so the PZ and the PY look exactly the same, only one's up and down and the other one's in and out of the board. So you can think of 2 of those. Then we've got the anti-bonding orbitals, right? So those anti-bonding orbitals is where I bring my 2 nuclei together, right? And then the 2 are side on, and they push apart from each other. And they push apart because those phases or those colors are different. Okay, so you have a node in the middle, there. And the last one is this px anti-bonding orbital. So that's where I take these ones and I try and push these lobes together. Right? And so for oxygen, this is the order of those orbitals, or where the electrons can be. Okay? So when I look at this, I've taken all my electrons, I put them in the molecular orbital diagram, starting from the bottom, going all the way up to the top. I can calculate bond order. Bond order is 1/2 times the bonding electrons minus the anti-bonding electrons. So here I'm going to bust out my yellow pen and count the bonding electrons. We've got 1, 2, 3, 4, 5, 6, 7, 8 bonding electrons minus the number of anti-bonding electrons, which is right here. We've got 2, 3, 4, minus 4. So bond order equals 1/2 times 4, or 2. Right? So when I draw the Lewis structure of this, I can draw my oxygen with 2 bonds to the other oxygen. Okay? So this is the setup for like every single element that's not a carbon, boron, or nitrogen. Remember, so if you have boron, carbon, and nitrogen, the pi bonds are lower than the sigma bonds. Okay? So takeaway, this is the order, right? If you draw the 1s or you hear about the 1s, they're at the bottom, they look just like the 2s. But all atoms have this pattern where sigma is lower than the pi bonds, except for boron, carbon, nitrogen, when the pi bonds are lower than the sigma. So in your on your homework, it will ask you for the electron configuration for the molecular orbitals, okay? And so what they do is they start at the bottom and they just, they write down the electron configuration or where the electrons are at. So if I started here, this bottom one is called sigma 2s, and there's 2 electrons in that, okay? The next one is sigma antibonding 2s, and there's 2 electrons in that. The next one is sigma 2px, and there's 2 electrons in that. The next one is pi 2py, and there's 2 electrons in that. Pi 2pz, and there's 2 electrons in that. Pi antibonding 2py, and there's 1 electron in that. Pi antibonding 2pz, and there's 1 electron in that. And then sometimes they'll have this last one and say 0 electrons, or sometimes they'll leave it off. Okay, so this is the electron configuration for the molecule. They start at the bottom and just kind of label their axes, or they label where their electrons are at. Okay,